Welcome to G Fun Facts Online. Today we are leaving the surface of the Earth to chase down a mystery that has been hiding in plain sight. When you look up at the night sky, you see the moon. It has been our constant companion, the keeper of tides, and the light in the dark for billions of years. But ask yourself this: what if the moon was not alone? What if Earth had a second moon, a secret companion, disguised as an asteroid? This is not science fiction. This is the reality of an object known as 469219 Kamooalewa. As of late 2025, this spinning rock has transformed from a simple celestial oddity into the target of one of the most audacious robotic missions in human history, China's Tianwen-2. We are going to break down exactly what this object is, why it might be a lost piece of our own history, and how humanity is currently attempting to harvest a piece of it. Let us start with the discovery. The story begins back on April 27, 2016. Astronomers in Hawaii were using the Pan-STARRS 1 survey telescope to hunt for near-Earth objects, or NEOs. These are usually rocks that pose a threat to our planet. Amidst the noise of thousands of asteroids, one signal stood out. It was designated 2016 HO3, later named Kamooalewa. This is a Hawaiian name found in the Kumulipo creation chant, meaning an oscillating celestial object. The name is perfect because of how this thing moves. Most near-Earth asteroids just fly past us. They have their own independent loops around the sun. But Kamooalewa appeared to be looping around Earth. To understand why this is special, we have to talk about orbital mechanics. A true satellite, like our moon or the International Space Station, is gravitationally bound to Earth. If the sun disappeared, the moon would stay with us. Kamooalewa is different. It is what we call a quasi-satellite. It orbits the sun, not Earth. However, its orbital period is almost exactly the same as ours, 365 days. Because it shares our year, it never strays too far from us. To an observer standing on Earth, it looks like it is tracing a complex retrograde loop in the sky, hovering like a wingman. It travels in what is known as a horseshoe orbit. It exists in a delicate gravitational balance. Over decades, it drifts slightly ahead of Earth, and then slightly behind. When it gets too close, Earth's gravity gives it a nudge, either speeding it up or slowing it down, causing it to shift orbits slightly. It is a game of cosmic tag, where the asteroid is the hunter and Earth is the chaser, but they never actually touch. While most quasi-satellites are temporary flings that drift away after a few years, simulations suggest Kamooalewa has been with us for nearly a century and will remain for millions of years. It is the most stable quasi-satellite ever discovered. Physically, Kamooalewa is not a giant. Estimates place its diameter between 40 and 100 meters, roughly the size of a Ferris wheel. But do not let the size fool you. This is an energetic object. It spins furiously, completing a full rotation every 28 minutes. This rapid spin is a crucial clue. It suggests that Kamooalewa must be a single, solid monolith. If it were a rubble pile, which is just a loose collection of gravel and rocks held together by weak gravity, it would have flown apart spinning that fast. Despite being our companion, it never comes closer than 14 million kilometers, which is about 38 times the distance to the moon. It is close enough to be a neighbor, but far enough to keep its secrets. That brings us to the big twist. In 2021, a team of astronomers led by the University of Arizona used the Large Binocular Telescope to look at the light reflecting off this rock. In astronomy, light is a fingerprint. By breaking it down into a spectrum, scientists can determine the chemical composition of an object. They expected to see the signature of a typical silicate asteroid, perhaps something from the inner asteroid belt. Instead, they saw something that made no sense for an asteroid. They saw reddened silicates. The spectrum did not match the asteroid belt. It matched the moon. Specifically, it was a near-perfect match for lunar samples brought back by the Apollo 14 astronauts. The silicate mineral showed signs of space weathering, which is the darkening and reddening caused by exposure to the solar wind and micrometeoroids, exactly like the dust on the lunar surface. This leads to the Giordano-Bruno hypothesis. If Kamooalewa is a piece of the moon, how did it get out there? We know the moon has been bombarded by asteroids for billions of years. While most debris falls back down or rains on Earth as meteorites, a tiny fraction can escape the Earth-Moon system entirely. But to escape and then settle into a stable, Earth-like orbit is a 1 in a million shot. In 2024, a study in Nature Astronomy proposed a smoking gun. They used computer simulations to trace the orbit backward in time. They needed a lunar crater that was large enough to eject a 50-meter rock at escape velocity, young enough to match the asteroid's relatively fresh exposure, and located on the trailing hemisphere of the moon to launch it into an Earth-trailing orbit. The search pointed to one candidate, Giordano-Bruno. This is a 22-kilometer wide crater on the lunar far side. It was formed by a massive impact, just a few million years ago. That is a blink of an eye in geological time. The event hurled millions of tons of rock into space. Most were lost, but one chunk, Kamooalewa, threaded the gravitational needle to become a permanent exile. This theory is compelling, but science demands proof. That is where TIANWEN2 comes in. Following the success of TIANWEN1 on Mars, the China National Space Administration launched TIANWEN2 in May 2025 aboard a Long March 3B rocket. As we speak, this probe is hurtling through the void. This is not just a sample return mission, it is a technological gauntlet. The spacecraft weighs over 2,000 kilograms and is equipped with solar electric propulsion using ion engines to spiral efficiently through deep space. It carries 11 scientific instruments, including high-resolution cameras to map the surface in sub-centimeter detail, spectrometers to confirm that lunar composition, and magnetometers to study the solar wind. But the defining challenge is the landing. Remember, Kamooalewa is spinning once every 28 minutes and has almost zero gravity. You do not land on it, you dock with it. A standard touch-and-go maneuver, like NASA used on Bennu, is too risky here, because the centrifugal force could fling the spacecraft off before it grabs a sample. To solve this, Chinese engineers developed the anchor and attach method. The spacecraft has 4 robotic arms ending in ultrasonic drills. First, it will match the asteroid's spin, hovering just meters above the surface. Then, the arms deploy and fire anchors into the rock, physically clamping the spacecraft to the asteroid. Once secured, the spacecraft effectively becomes a new appendage of the asteroid. With a stable platform, a separate sampling drill bores into the regolith to collect up to 100 grams of material. This allows TIANWEN2 to stay on the surface for a prolonged period if necessary. So why does this matter? Why go to all this trouble for a handful of dust? The return of these samples, expected in late 2027, will be a watershed moment. First, it gives us the missing link of the Earth-Moon system. We have moon rocks from Apollo, and we have meteorites. But meteorites are dirty. They burn through our atmosphere and get contaminated by Earth biology. Apollo samples are local, from the near side. Kamooalewa likely comes from the far side, a region we have barely sampled. By dating these samples, we can precisely date the Giordano Bruno impact, which acts as a calibration point for aging surfaces across the entire solar system. Secondly, there is the concept of lithopanspermia. This is the profound idea that life could be distributed between planets via impact ejecta. If a massive rock hits Earth, could chunks of Earth-carrying hardy bacteria be knocked into space and land on Mars? Kamooalewa is proof of concept for the transport mechanism. It confirms that large, coherent chunks of a planetary body can be ejected into stable orbits where they survive for millions of years. If Kamooalewa were a chunk of Earth instead of the Moon, and if it carried microbial spores deep inside its fissures, it would be a seed ship, waiting to collide with another world. Studying the organic contamination, or lack thereof, on this rock will help us understand if biological material can survive the shock of ejection and the harsh radiation of deep space. Thirdly, there is planetary defense. Kamooalewa is a near-Earth object. To deflect an asteroid, you need to know if it is a solid slab or a loose bag of gravel. Its fast spin suggests it is a monolith. TIANWEN2's drilling data will provide the first direct measurements of the mechanical strength of such a body, which is vital for designing future kinetic impactors or deflection devices. Finally, let us look at the future horizons. The stability of Kamooalewa's orbit has led to radical proposals. Because it stays close to Earth but has very low gravity, it is energetically cheap to reach. Some visionaries propose using it as a way station, a resource depot, or a staging ground for missions to Mars. Its orbit is essentially a parking spot in interplanetary space. TIANWEN2 will also test for hydrated minerals. If there is water locked in that rock, it could be mined for fuel. But the mission does not end there. After dropping the sample capsule into Earth's atmosphere in 2027, the main spacecraft will fire its ion engines for a new journey. Its next target is 311P Pan-STARRS. This is an active asteroid, a weird hybrid that resides in the main belt but sprouts a tail like a comet. Scientists suspect these are the remnants of icy worlds that shattered, potentially the source of Earth's water. TIANWEN2 will arrive there in the mid-2030s. As we watch TIANWEN2 sail silently toward its rendezvous, we are reminded that the solar system is not a static clockwork mechanism. It is a dynamic, violent, and interconnected ecosystem. Kamooalewa is not just a rock, it is a mirror. It is a piece of our own history, torn away by fire and preserved by the cold vacuum. When that sample capsule streaks across the sky in 2027, landing in the grasslands of Inner Mongolia, it will bring back more than dust. It will bring back a story of separation and reunion. A fragment of the moon that went on a million-year odyssey to become a quasi-moon, only to be caught by the curious hands of the species that evolved on the blue marble next door. That is all for today's deep dive. Thanks for listening to G Fun Facts Online.